On this video we're going to look at the non-parametric tests for looking at two samples. In the first test we're going to look at the Mann Whitney U Test, which is for looking at two unrelated samples that are independent of each other. In the second one we're going to look at the Wilcoxon, or in full the Wilcoxon Signed Rank Test, which looks at paired data. So it's a repeated measures test before and after and that type. Here we've got the data for the Mann Whitney U Test in Jamovi, and here we've got two sites, A and B, and at each site we've counted the number of voles. This might be for looking for potential release of barn owls or whatever it is, a wildlife conservation experiment. But we are going to try and analyse the two sites and see which one has the higher number of voles, if any. Okay. In Jamovi we set up site as a nominal category variable here, and vole count, you can see with the little ruler, is a continuous variable, and that makes it right. And we've got the data in a so-called long format, so we've got a treatment column or a factor column, and then we've got an outcome variable column instead of the wide format that we'll see in the Wilcoxon test. So the first thing we're going to do is have a look at the descriptive statistics. We're going to click Exploration in the analysis window and go Descriptives at the top. And here we're going to add the vole count with the ruler to the variables list, and then site we're going to split by putting the arrow there. So this is our factor or grouping variable. And here we've got a descriptives table with site A and B and our different statistics down the side. And we've got some of the key ones here already. We've got the median, which is useful for our non-parametric statistics, and we can often compare the mean and median to see if they are normally distributed or not. We're going to assume that these are not normally distributed because they're count data, but we're not actually going to assess that in this particular exercise. I actually prefer having the descriptives for this kind of exercise across rows, variables across rows. You'll see that here we've got site A and B, and then we've got all the statistics going down. If we do it across the rows, I just find it a little bit easier to compare the two sites across these values. Ideally, site A and site B would have its own column, but then we'd just be looking at individual statistics. Jamovi doesn't give us that directly. So here we're going to add a few more useful statistics for this non-parametric test, and one of the key ones to go with the median. So standard deviation goes with the mean. The medians generally go with either minimum and maximum values, but more often with quartiles. So we don't have anything that looks like quartile on here, but actually the quartiles are in this percentile box. So the 25th percentile is the lower quartile, so it's 25% of the way up. The 50th percentile is actually the median, the one in the middle, and the 75th percentile is the upper quartile. So if I just put a tick in that box, hopefully we get those 25th, 50th and 75th, or lower quartile, median and upper quartile there. You can see that the median there is the same as this one. Okay. The other one which is useful to have, because we're going to talk about this in a moment when we're looking at outliers, is the concept of the interquartile range, which is the upper quartile take away the lower quartile. So I'm going to put a tick in that box too. It's going to add another value just here. Okay, and there's the values that I'm going to take into Excel. In addition, I want to do the actual test. So the Mann Whitney test doesn't have a particular entry in our menu in Jamovi. The graphic user interface is quite simplified and really good for teaching, but here we actually find the Mann Whitney test and the Wilcoxon test in our t-tests box, because t-test is a test of two samples, either paired or unpaired. So we're going to basically carry out a t-test, independent samples in this case, and I'm going to again reload this with site as the grouping variable. You see the 3 circles there, or 2 circles and an A there, and vol count with the ruler there. So there's done a t-test, but I don't actually want the t-test. I actually want the Mann Whitney U Test, which is here. So I'm going to put a tick in that box, and I'm going to take the tick away from that box because that's no longer needed. Okay. So here I can see this is the result of our test. There's our test statistic, the actual U value, 23.5, and we could look that up in a table, or the modern statistics package gives us an exact probability. So this is the probability of the null hypothesis that the two sites are the same, and here we can see the chances of them being the same is only 0.018, or actually 1.8%. So it's very unlikely that the sites are the same, which means they are different, significantly different in this case. So here I can right click, I can write and copy all. So I'm going to copy this, and then I'll go to my Excel sheet, and I can paste. I can either paste it like this with all the tables, but I quite like a clean one, so I go for the paste special text only here. And there's all my numbers. So I've got my descriptives, and I've got my p-value here. So here I've got the data for setting out my tables. So here I would use the median and the lower and upper quartile within that descriptive stats, and there's my p-value that I could include in the table. Or I could produce a graph. Now an appropriate figure or graph for these data is the box plot. I'm just going to make a bit of room for myself, so I'm going to select these data and I'm going to move that over to the right. That gives us plenty of room. We'll come back to those soon perhaps. So here I've got data in the long format with the site A and B data stacked on top of each other with a factor column and an outcome variable column. Or I could take this outcome variable column and put it in a so-called wide format, so with site A and site B next to each other. Actually, this turns out to be much better for producing the box plot in Excel. If I take this one and I insert and I put in here, this is on the histogram button, that's where I find the box and whisker plot. If I put that in there, it gives you a reasonable box plot, but you'll find trouble later on in trying to add a proper legend and things like that. For example, if I add the legend here, it gives you vol count. We don't want that. We want site A and site B in the legend. So that's not the right answer. So we'll delete that one, and I'm going to select these data instead, including the blank spaces and the column titles. We go to Insert, and we put in histogram, and we go to the box and whisker plot again. There we go. We've already got 2 colours. That's a good start. We're going to start off by deleting things we don't need. We don't need a chart title there. Figures have their title at the foot and certainly not at the top like that, and we usually add that in the dissertation or the Word document afterwards anyway. So I just select it and press delete, and it's gone. These horizontal lines are distracting, so I'm going to click on those, and that selects them all, and then I press delete, and they're gone as well. And then there's this one. Not sure why that is there, but we don't want that either. In fact, we don't need that x-axis label. Okay, so here we've got the 2 box and whiskers. They're not very clear so far, so let's tidy those up. If I click on the blue one, if I right click it actually, I could go to the format data series, but very quickly I can go to the fill instead. Instead of having that darker blue, I'm going to go for a pale blue. And then for the other site, I'm going to go, which happens to be site B, I'm going to go for the fill. I'm going to go for the pale red pink colour, because now you can see much more detail. You can see this X in the middle and the line. The line in the middle represents the median, and the X represents the mean. So we got a few extra details on there than you get on some of these box plots. This is the lower and upper quartile, and these whiskers, which is what we call these long sticks, this is the minimum and maximum value that lies within the interquartile range from these quartiles. So if we look at our interquartile range for site A, for example, let's just highlight these in bold so you can see them better. The interquartile range, as in the gap between here and here, is 9.75. Well, actually, how Jamovi and lots of stats packages work as standard is to take that interquartile range of 9.75, and then anything that's within 1.5 of those, so that's about 14.5, above there is included. So this is the maximum value within that range. Anything beyond that range is classed as an outlier and is indicated by dots. We don't have any outliers in this study, but if you see dots above or below the plot, they are 1.5, at least 1.5 of the interquartile range above or below the quartiles, this box thing. Okay. More simply, we've got a lower quartile at the bottom of the box, an upper quartile at the top of the box, and the median in the middle. And here, forgetting the outliers, is the minimum and maximum. We'll put that in the label in a moment. So, what else have we got to do? We've got to add a few chart elements to here. So let's do that. We'll click on the graph, and then we click the plus sign, and we need to put in an axis title, but only on the y-axis, the one going up the side. So we don't need the horizontal one, but we do want to put a tick there. And here, well, we just delete where it says axis title, and we'll add fold count, because that's what we did. We haven't got this bottom axis, because actually what would be preferable to that is to add a legend. And you can see when I click legend now, it puts site A and site B in nice pleasing coloured boxes. I can do a bit more with that. The Jamovi was quite limited in what it does with a box plot. So here, if I right click this and go to format legend, I've got a number of options. First, I can control its position. It's at the top, but I quite like having it at the side. It's less distracting, but it's a little bit out the way in Excel by default. But here, that's because the tick is in the box saying show the legend without overlapping the chart. Actually, if we take a tick out of that box, I think it looks a bit more balanced, a bit tidier. So that's quite nice as it is there. Okay, so we just need one more thing, really, two more things perhaps. We need to add the p-value. We've got a p-value there. To add there, we could add, this is a bit less pleasing, but we need to add a shape, a text box. So here's the text box in the insert menu. We're going to put a text box here. In that text box we could write p equals 0.018. That sits on the top there. We can make that a bit larger. We probably want to match the font to our thesis. Well, perhaps we wrote it in Arial, so we'll put that there, and that's looking good. And in fact, if I select the whole graph, I can change all of the fonts at the same time, so they're all now in Arial. I've got a grey box around that p value. Probably don't want that. So here on this side, we've got a fill and a line, and currently it says a solid line. I don't want it. We get no line. That looks a bit tighter, doesn't it? Okay, the other thing we wanted a title. As I said, we'd normally put this in Word, but here we're just going to add it at the bottom, as if it were in a Word document. Figure 1, because this is a figure, and we're going to call this, well, it's a vol count, is what we measured. And how do we compare it? Well, they were at 2 potential release sites, A and B. And then we need to tell our audience, what does the box plot represent? So the box plot shows the median, the quartiles, and let's go on to the next line, the maximum and minimum values. And then if we were presenting this with outliers, we could write this extra part, excluding outliers beyond 1.5 times the interquartile range. That's if we were including outliers, but in this case we don't have any. So I'm going to delete that part because it's not relevant to this particular graph. But we should include it if there are any. So let's make that a bit tidier. And actually we should really put the mean in there as well, because that X represents the mean. And that's our box plot for our Mann Whitney U test. For our Wilcoxon test, in full the Wilcoxon Signed Rank Test, as opposed to the Wilcoxon Rank Sum test, which is actually exactly the same as the Mann Whitney test, and unhelpfully named with Wilcoxon as well. Anyway, this is the Wilcoxon Signed Rank Test. We have the data in the wide format. We have a grouping column or a factor column, which is the cells. In the individual cells here, and remember with the two circles and the little a, that's a nominal variable, because cell A was measured in August for her salivary cortisol and again in November. So those two values are paired or repeated measures from cell A. These two values are repeated from cell B. So we need the data in this slightly different format, not in the long format but in this wide format. To do the Wilcoxon analysis, we go for the analyses menu, and like the Mann Whitney, it's not there immediately, it's actually within the t-tests function system. So we go to t-tests, and this one is a paired sample. So we're going to go to the paired sample t-test, and we're going to add our variables. And this is a slightly different format to every other test in that we put August and we move it into the paired variables column, and it's on the left side of a pair, and then we move November to the right side of the pair here. And it's already done our paired t-tests automatically, but we don't want that one. So we're taking a tick out of that box and we put a tick in the Wilcoxon box. So this gives us the p-value, and here you can see there's a significant difference between August and November. What this doesn't give us is the actual data that we want. And we could click on descriptives, and that gives us the median value, but this is set up for t-tests, so it's got the mean and the standard deviation or standard error, but it doesn't have the quartiles. We're going to have to go to our full exploration and descriptives in Jamovi for that. So we'll take the tick out of that box to tidy this up. We've got our p-value from the test, but we're going to go to here, the exploration descriptives, and here we're going to add August as a variable. We're going to add November as a variable, and there's all our descriptives coming up. Again, I quite like it across the rows instead here. Let's keep this nice and simple compared to last time. With the statistics, I'm going to take the tick out of everything we absolutely don't need. We don't need the n, there's 13 in each. We don't need the missing ones. We don't need the mean. I'm going to keep the median. I don't need the standard deviation. I don't need the minimum and maximum for my table or the interquartile range this time. I do need my quartiles, so I'm going to click in the percentiles one. That's going to give me the lower quartile. It's giving the median again, that doesn't matter, and it gives me the upper quartile as well. Okay, so that's what I need for my table, all of those statistics there. So let's take them back to Excel to do some basics, to get some work done. Here, I just right click here. I'm going to, instead of just copying this individual analysis, I'm going to copy all, which is going to take the descriptive statistics with me as well. I'm going to copy them. I'm going to go back to my Excel sheet here, and I'm going to right click, and I'm going to just choose the basic, the one on the right. I could do this one with all the formatted tables, but I'm going to go for the one on the right because I'm going to make my own tables here. I don't need these references from Jamovi. Okay, so what do I need for my table? I need the p-value. I need my median. I need my lower quartile, and I need my upper quartile. That's what I need. Okay, so let's create a table here. So I'm going to have at the outcome, I've got the salivary cortisol, and I need to add the units. So actually I don't have the units up here, but salivary cortisol is measured in nanomoles per litre, and if this was in the exam you would have been given that. So here we close the brackets, so that's on one side of our table. Let's do that up here so I can make it a bit tidier. Okay, and then we've got August and November. So here in August I want to present the median and the two quartiles here. So the median was 10. I'm going to make it 10.0 because that's going to match the data in these tables. Strictly speaking, I could do it to 2 decimal places, but 1 decimal place for these non-parametric data is perfectly reasonable here. So, and then in brackets I'm going to put the lower quartile, 8.3, and a comma, and then a space, and then I'm going to put the upper quartile, which is 13.4. And that's my data for August. Let's give it a bit more space. And then November, I've got a median of 15.3. Notice that cortisol seems to have gone up in November. They seem to be more stressed in November. And I'm going to open the brackets, and I'm going to put the two quartiles. It's 12.7 for the lower one and 16.3 for the upper one. So that's pretty much my table right there. Okay, I would need a table title. Let's give it a proper title. Table 1 here. Well, we've measured salivary cortisol levels from sows, and here we had 13 sows. So let's put that in there. N equals 13, measured in August. August and November, and we must say what the data is actually showing, and that is the median and quartiles. Now this is a table, so the table title will go at the top. Now we'd actually do that in Word, and we put the lines in and we make the table look a bit tidier, but essentially that's what we need for our Wilcoxon. If you wanted to do a box plot instead, go back and have a look at the Mann Whitney notes that came earlier, and you'll see how to produce the box plot. It's exactly the same way. You would have just selected those 2 columns of data there. There we go. Mann Whitney U Test or Wilcoxon Signed Rank Test. Thank you for watching.